Which two of these graphs represent the inverse of each other? I will give you a hint. One of them is this. So you've got the choice of A or B. Which one of those represents the inverse? The inverse. Now, I will remind you that we said to be an inverse means it had to be a reflection across this line, y equals x. So now, discuss with your neighbors which one you think it is. Which one of those is a reflection across that line? Go. Okay. Which one did you pick? A is correct. The reflection. So the part up here in quadrant 2 becomes this part here in quadrant 4. It flips across that line. We talked about how you switch x's and y's. That's how you get an inverse. You switch x's and y's. What happens with the domains and ranges if you're switching x and y? They literally switch. That's it. They want me to graph this. They want me to find domain, range, x-intercept, asymptote, end behavior of the graph. Do we know what y equals 2 to the x looks like? I really hope so. Could you describe it to me? What would you call y equals 2 to the x? Literally, we don't have a good description for it in like 2 short words. Oh my goodness, you guys can do better than this. All right, you got about 15 seconds to come up with a phrase for that one. Go, talk to each other. What's all that? I know, but we'll get to that part. I'm asking about y equals 2 to the x. Definitely not quadratic. I already did. It is definitely important. You call it. It is. So you got one of the words off the board. Well, yes, it is a function. But I'd like to know what you think it's supposed to be. Okay. Why do you say that? Yeah. All in one, right? What did you guys say? Yeah. You know, I was hoping you would say exponential growth. Because we studied it already. Yeah. Right. It is good important to talk to people. So exponential growth, we all know, looks something like this. Let's see here. What's the asymptote on this particular graph? If you do not quote the equation of a line, you do not get the credit. What is the equation of the asymptote? Y equals 0. That's true. It's a horizontal asymptote. You know, every time we do those kind of things, I do like a dotted line like this, kind of like you did on your last quiz, which I'm still working on grading. All right, so what's the domain? Negative infinity to infinity, which goes along with the phrase you just said, all reals, but I would rather see negative infinity to infinity. And how about the range? Amen. Nicely done. What's the y-intercept? What's the y-intercept in this graph? 1. Thank you very much. Remember we said y equals ab to the x. The a value, the value that's in front of the 2. Oh yeah, that's a 1. Right. So this is the coordinate 0, 1. Yes, I know, folks. We can go through and make a table and have a 1 and a 2 and a 4 and a 1/2 and a 1/4. We can do all that. We know how to type on a calculator. So what happens when you switch the x's and y's? Yeah, that's going to be -2. And that's going to be -1. And that's going to be 0. And that's going to be 1. And that's going to be 2. What the heck is the picture going to look like if we do that? Is it going to look like this thing that you got right in front of you? Now, it kills me all the time when I say, please graph the logarithm function. And you know what I get? I get kids that draw this entire picture. Now, first of all, is that entire picture with the red one and the blue one, is that a function? No. How do you know? Doesn't it fail the vertical line test right through here pretty easily? So when we're saying graph the exponential, that would be the red one. When we're saying graph the log function, that would be the blue one. What's the domain of the blue one? What's the domain of the blue one? Isn't it 0 to infinity? What about the range? Negative infinity to infinity. What about the x-intercept? Isn't it 1, 0? What about the asymptote? X equals 0, right? We've got a vertical asymptote, not a horizontal one. End behavior. As x is getting closer to 0, what happens to y? So you're going like this. You're getting closer to 0. What's happening to the y? It's going down, 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 down for a long way. And what's happening as you go to the right? As x is getting bigger and bigger and bigger and bigger, what's happening to the y? It's getting bigger and bigger and bigger. Now, does it get bigger at a fast rate or a slow rate? If you're looking at that blue one and you're moving to the right for a long way, do you think it's going up fast or slow? It's going up slow, isn't it? Now, yeah, the red one goes up very fast when you go to the right. But the blue one The blue one's only going, it is going up though. Not stopping. What kind of numbers can you plug into a log function? The logarithm function accepts what? MasterCard, Visa, Discover? What kind of numbers can you take the logarithm of? According to that picture. What are the only possible numbers you can plug in for x? Positive numbers. You can't plug in 0. That's the vertical asymptote. You can't plug in negative numbers. We already talked about that. This picture verifies it. I have already drawn one of these out for you before so that you would understand, because I think the picture is kind of useful, in my opinion. Graph the function. How did the asymptote and the x-intercept of the graph function compare to those of the parent function? All right, what are you seeing inside there? That's on the inside, right? That's a change on the inside. What do we know about changes on the inside? They go opposite of our common sense. And so what do you think is happening? What does this mean? Left 3, right? I need you to make that conclusion. So we've got this logarithm graph, the blue one. Everything slides over to the left 3 places. Everything. Can you tell me what the vertical asymptote is? It used to be x equals 0. So I would expect on your graph, if I ask you to sketch this, I would expect a dotted line at x equals -3. I would also expect that you wouldn't cross that line because you know it's an asymptote of the graph. It's also, if I need at least 1 point, if I told you to sketch it, I would expect a vertical asymptote. I would expect the basic shape to be the same. And what would be one fantastic point to take off the blue one and use on the red one? What would be one point that would be a great one to take from the blue one and make sure it was on the red one? The x-intercept, right? I literally am going to take that 1, 0 and slide it over 3 places to the left. Yes, we can get very specific and we can plot all kinds of points. But typically, I'm just going to ask you for a sketch. Now, are these things any different? ln x? Is that different? Let me ask you this question. Is it drastically different than log? Is it drastically different than log? No, it's not drastically different. Yes, it's a different base. I'll prove it to you. So they share the x-intercept 1, 0 in common, and they have the same basic shape. They have the same vertical asymptote, same domain and range. They're slightly different. When you come over here, what is this +4 doing to the graph? Keep in mind, folks, it's on the outside, not on the inside. What are we thinking? Up 4. Changes to the y are on the outside, and they match our common sense. I don't know how many times we've had to say that. So what's the big difference? How can I tell if it's inside versus outside? Parentheses. That's the big deal, folks. Parentheses. So when it comes to these logarithm functions, parentheses make the difference whether it's a left and right shift or an up and down shift. Okay? What's the change that you see here? Multiplication by 5. Notice that it's on the outside. So what's going on with that? Vertical stretch. Nicely done. Why did you choose the word stretch? Ah, because it's more than 1, right? Vertical stretch by 5. Now, what's that going to do to this graph? Here, we'll come up here and change this one. We'll make this ln. And then vertical stretch by 5. Did one point stay the same? What point? The x-intercept. Right? Because what's the y value of the x-intercept? 0. And when you take 5 and you multiply it by 0, what do you get? Still 0. Everything else got stretched. These points got stretched down. These points got stretched up. Now, is it basically the same shape, but just a little distorted? Yeah, it is. It is. It's got the same domain and range. So, whoops. Example 3. What is the equation of the inverse? Okay, so last thing you need to write, what's the first step in finding an inverse? Switch what? So please, in your notes, write this down before we walk out the door. Now you can go. Then y. Now we need to solve for y. What are we going to do? Logs. Thank you very much. Is that what you're going to say? Fill in the boxes. Go. Identify the base first. The exponent second. We know the exponent goes on the other side. But, you know, that is something we need to know how to do. What's the base? 10. What's the exponent on the other side? Y plus 1. And that leaves one box left, which is the x. Now we need to get y by itself. So y is what? Log x. Is it this one? Or is it this one? Which one is it? Is it the one on the left or the one on the right? Talk to your neighbors right now. See if you can decide. The one on the left or the one on the right? That's a good question right there. Okay, which one is it? The left or the right?
No. Oh, I see my instincts were right.
Your instincts were correct. Yes. When you're doing that subtraction, it is on the outside of the logarithm function. It is not this one. These two are inverses. And yes, you could call it f inverse of x equals log base, or log x minus 1. We know it's a base 10 logarithm. Okay, your turn. Start by switching x and y, and then solve for y. Go. After we switched x and y, we know we need to change it to its other form. What's the base? 7. What's the exponent? Is it x or y plus 5? It is x, leaving y plus 5 in the final box. We need to get y by itself. Subtract 5, thank you very much. 7 to the x minus 5. This would be g inverse of x. Whoa, it's a bad looking inverse. G inverse of x. That's another way to say the exact same thing. You need to know that those two things are the same. But we switch x and y, and we solve for y. You got to be good at switching back and forth between log form and exponential form. Ooh, that's an ugly looking picture down there. It's the reflection of the two across that line. Sorry, not a great looking picture. Example 4, a company uses this function to relate sales revenue and advertising costs. So A is advertising costs and R is revenue. What is the equation of the inverse of the formula? Which equation would be easier to use to find a value of A for a particular value of R? What would you do to get the inverse? Start by doing what? Yeah, it's that equivalent idea of switching the variables, but another way to understand this process in a story situation is to solve for A. This is the equivalent idea of switching the variables. Do me a favor right now, solve that for A. Okay, after you move the 25 to the other side, what'd you do? Divide by 12. Excellent choice. So log of A plus 1 equals R minus 25 over 12. Now what? What are you going to do to get A by itself? Got an idea? Got an idea over here? Yes. What's your idea? Change to exponential form. What a novel concept. What's the base? 10. What's the exponent? Your choices for exponent are A plus 1 or R minus 25 over 12. Yeah. R minus 25 over 12 equals A plus 1. So, what's A? 10 to the... Yep. Which equation would be easier to use to find a value for A given a particular value of R? Would you use the first one or the one we found? If I handed you a value of R and I said, give me an advertising budget. I want this revenue. Give me an advertising budget. It is the one we found. Because you would plug the R in and then start calculating. I would suggest if you are using a horizontal style calculator, that when you're trying to raise something to a fairly complicated exponent, if it's one of these blue calculators like I got over here, which I know a lot of you have, you definitely want to use parentheses around the exponent. If you're using Desmos Scientific or a calculator that has a vertical fraction, you won't have a problem with that. But the rest of us will. Example 5, compare two logarithmic functions. Logarithmic functions can approximate the altitude of a plane over time. Which plane's altitude shows the greater rate of change? Rate of change. Over the interval from 10 to 15. I'm guessing 10 to 15 minutes. Now, rate of change, what is that a fancy word phrase for? 5-letter word starts with an S. Slope. For the graph on the right, do we have two coordinates already? Yeah, we know exactly what coordinates we're using. Now, I have always recommended to you that you write those coordinates vertically so that you do not mix up your X's and Y's. Does the first one give you the coordinates, or do you have to figure them out? Yeah, we've got to figure them out. In other words, you're going to have to find them first by plugging those numbers in for the time, obviously one at a time. Use your calculator to find those, and then you need to find the slopes of each. So we can answer this question. And we saw a problem right here. It is a plus sign. It looks like a minus on the photocopies, but it is a plus. When we type those in, we got these values. So when we start this problem tomorrow from this spot, we will be finding the slopes. Section 6.4, we had plane A, plane B. And we figured out the 10 and the 15 for both plane A using the formula. And yes, it was addition, so we had to do that with Desmos Scientific or handheld scientific calculator. Sorry, it looks like a minus on yours, so please make sure you understand that it is a plus. The other one, they gave me the values. So now we need to find the slope. Difference in the y values. I like to write them in a vertical fashion so we don't screw this up. Minus the difference in the x values. The reason I like putting them vertically is so that we don't mix up x's and y's. And then obviously you want to do the same thing on the other one. And I know you've asked me before, does it matter which order you go in? Not as long as you're consistent, because you'll end up with the correct answer. So find those two slopes for me right now. Use your calculators to do it. Slopes ended up being 746 for the first one and 390.4 for the second one. It says which plane's altitude shows the greater rate of change. Obviously, it's the first one. But it's literally just finding the slope. They've asked this type of question in various forms for different models throughout the entire year. Can you look at those? Well, no, that's not going to be the correct question, so I'll back up. All right, let's go to the next one. Ooh, that's the end of that lesson. All right, we're moving on to 6.5.